Okay, so we are going to factor this polynomial. Now, notice in this case, right, first off, there's no greatest common factor. We'd want to look for that if we could. There is none. Now, there's 4 terms. We might think about factoring by grouping. This one's not going to work by factoring by grouping, though. Okay, obviously you can try it on your own, but it's not going to work. So now we're like, what do we do? So when our normal factoring techniques don't work, we go to what's called the rational root theorem. If something has what's called rational roots are fractional values or integer values. When the rational root will find them. So what I've done in the past is I've said, hey guys, x minus 2 is a factor. And what did we do? We took x minus 2, we used synthetic division to pull out that x minus 2, to factor out that x minus 2, and then we kept on going, okay? In this case, the hard part here is I'm not telling you what any of the factors are. I'm just saying factor this. Our job is to find that factor. So here's how this works. We're going to start with finding a list of all the possible rational roots. They're possible, that doesn't mean they all work. And here's how we do it. So we are going to take, how did we symbolize it? So what we're going to do is we are going to take P and we're going to do Q. P represents all the possible factors of 20. Be careful, right? For example, 20 and 1 are possible factors of 20, but also negative 20, negative 1 are also factors of 20, agreed? So what I'm going to do here is I'm going to go, all my possible factors I'm going to say, because everything can be positive or negative, so I'm going to say plus or minus, and I'm just going to start listing them. So let's see. 1 is a factor of 20, 2, 4, 5, 10, 20. So all my possible factors of this last term are plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus and minus 10, plus and minus 20. Okay? I'm then going to do the same thing, and this is kind of nice. I'm going to do the same thing for the numbers in front of the first term. In this case, would you guys agree the only possibles are plus and minus 1?
For the first one?
Yep. Yep. So in this case, that's really nice. This gets harder when this number's not 1. Okay? Question?
Would there ever be like a problem where there's not like just a remainder, there's no...
So that's a good question. So the question is, once we found all our rational roots, is it possible that maybe none of them work? Because if none of them work, that means there would be some sort of remainder. And that is possible, but you're not going to get that. Okay? What's going to happen? So all that means is it's not factorable it's not factorable in the ways we can do it. Okay? So the last thing we do is we are going to find all our possible factors. So what we do is we take P and divide it by Q. Would you guys agree with me? All that's going to end up happening is I'm going to take all these numbers and divide them by plus or minus 1. It's just going to give, in this case, it's just going to return all these numbers. Okay? So in other words, I'm going to get plus or minus. Technically, it would be 1 divided by 1, but that's still 1. 2 divided by 1, which is still 2. So these numbers aren't changing. The only time they would change, for example, if this was 2, then it would be 1 divided by 2, 2 divided by 2, 4 divided by 2, 5 divided by 2, right? But because this is 1, nothing's going to change. Okay? That's kind of your first half. So before I continue, is there anyone who doesn't know how we found those numbers? Okay, so again, the way we find those numbers is the first thing I do is I find all the possible factors of 20. All the things that multiply, all the possible things that go into 20 evenly. These were all the possible things that go into 20 evenly. I then do the same thing, all the possible factors of what goes into here. In this case, I think you'd agree the number is 1 that goes in here. All the possible factors, the only way you can make 1 is 1 times 1 or -1 times -1. To find P divided by Q, you take all these and you divide it by this. So 1 divided by 1, 1. 2 divided by 1, 2. 4 divided by 1, 4. 5 divided by 1, 5. And again, it's going to be plus or minus for each of those. Okay? From here, here's what we do. And this is where our synthetic division is really important. What I'm going to go through and do is I'm going to start trying out different ones. I'm looking for a remainder of 0, because if the remainder is 0, that means it's a factor. If it's not, if it produces a non-zero, it's not a factor. So I'm just going to start with the most obvious one. I'm going to just start with 1. I'm going to take 1 and I'm going to use synthetic division. All I'm looking for right now is I'm checking to see if this is a factor. So let's see here. For synthetic division, the number in front of x cubed is 1. Then it goes -8, +11, +20. Again, I'm looking for a remainder of 0. So bring down the 1. 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. Add those together, we get 4. 1 times 4 is 4. 20 plus 4 is 24. Would you guys agree? +1 is not a factor. Okay, or 1 does not evaluate in. It's actually x minus 1 is not a factor. Okay, 1 doesn't work, but maybe -1 works. You can see where this can get a little bit rough in that there's a lot of different factors, and it may be that it takes you a while to find them. Usually, just so you guys know, it doesn't take that long, but the nice thing is we can go through this pretty quickly. So let's see if this one works. So bring down my 1, -1 times 1. Huh? Is this one going to work? No. Oh, wait, it does work, doesn't it? 20, -20, 0. So this one works. We got lucky we got it in 2. Again, it is kind of lucky that we got it in 2. Usually I think I think of 2 being lucky. I think of 4 or 5 being unlucky. Okay? So here's what we do from here. Notice this worked. So we know that x plus 1 is a factor. Reminder, x plus 1 is the factor. It's the opposite of this number. And then we write out our polynomial, just like we did when we were doing synthetic division. So we're going to get x squared minus 9x plus 20. Again, all we did is we did our synthetic division and we rewrote it in factored form. The last thing we do is we look at this and we try factoring it. It's a 3-term polynomial. I'm just going to try guess and check. So in this case, I get x plus 1 times, looks like it's going to be -4 and -5. Okay? So one more time, let's review. We were given a polynomial that we couldn't factor through our normal ways. So what we did is we used this thing called the rational root theorem. We found all our factors of our constant term, plus or minus. We found all our factors of our highest degree term, the coefficient, and then we divided this by this. This gave us all the possible rational roots. Remember, it's all possible doesn't mean that they all work. As we saw, we then started trying, using synthetic division, we evaluated our function at a couple numbers, trying to find one that actually works. And we know it works when we get a remainder of 0. We found that -1 was a 0, so we knew that x plus 1 was a factor. And then once we factored, we could then continue factoring. Okay?